Okay, welcome back. We will go. We will try to fix the problems with this code, with the collision of the player. Yeah. Just okay. And hopefully things will go well. So I realized probably there is an easier way to do things, but okay, how do we do it? So there is this. I can try to show it with paint. Give me just a second. Okay. So I have this player, and then it has some velocity. I can just. This one is just cleaner. I have this player, and then there's a block here. And then this player has some velocity. And then I want to do, so it has some velocity. If the velocity has, like, if it's really big, this vector, then it can detect the collision from so far away that if we try to say, for example, velocity equal to 0, then it will stop moving way before, like way before even getting close to this block in the visual, like when it's drawn. So to fix this, there is multiple option, I guess. One of the options is that we have to cut this movement into multiple movements, smaller ones, and make them smaller movements, like smaller vectors. And then see how things basically go. Basically, and check each time if this thing is colliding with anything. Probably that's the easiest way to do things. And then if that's happening, then we can try to, so for example, oh, actually, I don't completely, oh, I thought that I know the answer, but then I don't know. I have some block, and then the player is just falling down. The distance is 1 block maximum. But it's enough to show that in the next movement, actually the movement could be more than just tile size. It could be 100 pixel movement, while the tile set is 32, for example. What I can do is to cut this thing into smaller 32 pixel movements, and then in each step I check the collision, and if there is no collision it can continue. If there is a collision, I will have to make this 32 pixel movement even into smaller pieces, like I don't know, like 6 pieces of 5, 6 or 7 pieces of 5 pixel. And once I do that, I will find on which of these small pieces I will have a collision. Then if I have a collision, I can make the movement 1 pixel and 1 pixel. I guess it's a little bit complicated, but what it does is that I can exactly get the last pixel for which I have a collision, like, and then stop the movement before the last pixel, which is quite good because, I mean, there is a cost here, of course. So the cost here is that I have to first check every tile in the row, every tile that is like surrounding this player. So my player is 4 times has 4 times r as height, and the width is 2 times r. And my R is 10 pixel, I think. And my tile size is, I don't remember, was it 32 or 16? The tile size. I will check though. It's either 16 or 32 pixel. Okay. So what this does is that this makes sure that the player will never pass over some small platforms of the size of the tile size. I actually can do the steps into, so for example, x steps to r minus 1 and y step for r minus 1. This makes sure that player doesn't hop any platform, because this is basically, I'm just considering the size of the player, and at the same time, the steps are big enough that many times I just have to do it once or twice for many movements. I don't have to do it many times. And then when there is a collision, I will have to make the steps even smaller. So that would be like I will find which step of this. So it's like going the way in big steps first, big jumps, and then find which jump gives us collision. For example, third jump of the big jump. Then try to cut down the big jump that we found into smaller pieces, first to, for example, 5 pixel. And then that would give us a middle size jumps. And at the end, when we find what middle jump gives us the collision, we can then do the 1 pixel size jumps. And this will give us the exact location of collision. And basically, because we will have the previous 1 pixel, we can just say, okay, the previous one doesn't lead to collision, so like if we move back like 1 pixel behind in the direction, then everything is okay. So how do we do this? So the first thing is that I will have to have, let me make this new one. So I have the player, and then, oh no, not print here. Or maybe I can just draw this again. I can actually draw this thing. Okay. So if this is the vector, well, I mean, it could, yeah, okay. It goes from this center to this center. We first calculate this small distance here. To this side, to the right side of this layer. And then when we do that, we get a point here. We call this, oh, sorry. We'll get a point here. We will call it B. This is A. And then we have a vector AB by calculating B minus A. When we do that, we have to get the length of AB. For example, I would call it just AB. And then I will put this these lines for the length of AB. And then divide this vector, divide by length. Of course, if the length is not 0. And then we get what is called the direction or normalized direction of this vector AB. And this is the length. Now what we do is to make steps, and the steps could be 2r minus 1. So we divide this AB by 2r minus 1 to get the step value. I mean, first step. And then we hop with this value each time to get to the end of this point. We get the position at the end, and then we see if there is a collision there as well. If there is no collision, in between, that's okay. If there is collision, then we will have, for example, in step 1 equal to I, we have a collision. Then what we do is we will run the same thing for step 2, which is probably 5 pixel, I guess. So 2r minus 1 is like 19, because my r is 10 here in the game, but I could increase it later on. Hi, how are you doing? Bro, it will be much easier for you to present something. I don't have it. I will try to install it. Zig is programming language, low-level programming language like C. Welcome to the chat. What is Kelly draw? I mean, I'm not drawing as much. It's just that. Ooh, that's an interesting thing. Okay. And there is arrows and stuff. Thank you. It's an interesting thing. Okay. Interested. There don't have to be installed. Okay, it's yeah, I see. It's a website, and you just choose and start drawing, right? Or I have to be. Thank you. How do you do this? Do I have to have an account here or? Oh no, okay, I see. Ooh, that's really good. Okay, I can actually change this to, let's change the view to that one. Account is, no, there is no account. Yeah, I don't press U. You don't have to use it. What I mean is the, no, I see that it's really useful actually. It's good for prototyping. Yeah, it's really good. But actually, what I wanted to explain is done. So it's just that to remember what I wanted to do, I can just draw it somewhere. Augmentation, that's not what I want. Okay. You should be able to see it. Okay. Listen. Okay, so we have a player, and then we want to move this player to a new position. There. Can I move this thing? Yeah, okay, very good. It's super easy also to use. Then we do it. So first thing first, there is a rectangle that basically covers this thing, this shape of the player that we have. We want to extend this thing. Okay, I'm going to use the color. We will calculate the direction normal of this thing. And then how do you write text here? We get the normal vector. Okay. Yes, collision hotkeys. Oh, sorry, I just missed. You had a lot of messages. Carry on, listen. It's great. You can use hotkeys on keyboard to switch between drawing types and options. Yeah, I see there is one here, so I guess 1, 2, 3. Yeah, okay. And then, oh yeah, collision, yeah. Like a ellipse or rectangle. So the player that I have, the collision shape that I consider for my player is currently a capsule. It's not an ellipse, it's a capsule. So where there is, so how do I show this? Oh yeah, okay, here. It's 4 times R, and this is 2 times R. And then, so the half circles that are there, how do we do here? I think we can do a square and then half circle here. Oh no, I will have to move it there. There is a half circle up, there is a half circle down. Okay. Okay, and then what is happening is that this thing, this circle has, oh, I have to use another color. I can probably do Control Z, yeah. So this thing is R. The brush is too big. How do you change the size of the brush, by the way? No, it's not this one, is it? Share the code on GitHub. I'll take it. Yeah, yeah, exactly. So the link is in the GitHub. The link to the GitHub page is in the description. Oh yeah, okay, it's good. So the size of the circle is R and size of the square is 2R. Oh, that's kind of Z. 2R. It's there's hail here, so you might hear the sound. Yeah, exactly where it wanted. Yeah. So what's happening is that I will have to calculate the continuation of this vector to get this point here on the edge. I have a length for this thing. I mean, I will have a length for this thing. I will call it, for example, L. I will cut the L in some size, call L divided by 2R minus 1. This gives me step 1. Okay, I clicked on your repo and it says 404 page not found. Maybe is set to private. Really? Let me open my GitHub. Or maybe I can check the link. Maybe the link isn't good link. Um, on GitHub. It could be, yeah, it could be somehow private for some reason. I will just try to check that. Zig Ray. Where is the setting of this thing? It's here. It's not here. Where do you check? Oh, it's private for some reason. Wow. Okay. I don't remember. How did we check? Oh, okay. I have to go to my repositories. I will. Oh, it's okay. I don't have anything to hide. And then here. Where is this thing? What was the name? Okay, this one. How did we do it? I don't remember. It's this one, no? There was, oh no, setting here, sorry. Setting tab, yeah. Okay, I always miss this setting tab for some reason. Where is the change visibility? Change it to public. I'll make this public. I read and I understand. Make this repository public. Okay, I will have to change the view a little bit. Okay. Let me check if it's public now. Yeah, it's public now. You should be able to access it. Thank you for saying. I hope that, yeah, you can let me know if there's still problem. Yeah, but in principle there should be no problem. Yeah, okay. Okay, so what should I show now? Okay, we go back to whiteboard. Okay, here. So that's the step one. So, and the next step, I will have to cut movement in. I will find a collision. For example, in step one, equal to I have collision. Then I will break down this step into, for example, value 4. Step 2 equal to oh sorry, this is gonna be crazy. Let me try to okay, and then I will use the step 2 when I find a collision with step 1. For example, with 4 pixel, and then in the last one, 1 pixel. That would drop down the number of loops that we have to do, I guess. So, for example, if the distance is like 180, because the velocity of the player is too high, there is 180 distance between the player and some block. I can check the collision in steps. And then that would mean that I have to do it. For example, if it's 19, that would be like 10 on maximum, I guess. That would be 10 times. And that should do it. And then, for example, in index 9, I found collision. I will try to do the second step with 4 pixels. And then 19 divided by 4, that would be 5 loops there. And so in maximum, it's going to be like 20 loops just to get 180 distance, which is pretty good. Especially we'll have a lot of jumping and a lot of calculation with the, like when we jump, like that's the maximum value of speed. Like we'll have that more often for the platformer that we design here. Now, the next interesting thing that I was trying to look at was that if I have, so here, let's go back to the code. Okay, in the complete mess that I have created here, there are some interesting things that I have to change. It's not just the steps, but also that I'm using tiles. So what I'm doing is that, so this is the game, yes, this is the structure, my game struct. And then there's a tile set, which is a hash map. And I have a vector for the location of each tile. And then I have a tile type, which could be empty or block. But then I can change this tile type to some PID, like platform ID. And because I'm breaking down the platforms into smaller tile size things, so instead of I have the tile system, but I don't want to use it to check all the tiles like one by one. I can just do. I want to use this tile system so that it makes things faster. I don't see things being faster here that easily. I mean, necessarily. I can instead. What I can do is I will save the platform ID of that each tile represents, and then I can only check the platforms once. I don't have to check the each tile that corresponds to a platform. And that would be like only one check instead of, for example, 10 checks for, or I mean, that's maximum. It could be like 3 or 4 checks for each platform. I mean, it reduces the number. It's more efficient. Is there anything else that could help? I don't know. But this is not. This is like I don't know how to say this. This is like more like, because the number of tiles that we're gonna check every time is gonna be 10, for example. And if we have for each step, we will have like 10 tiles to check. And then if there is 3 or 4 steps, that would be 3 or 4 times that's like 30, 40 checks. Just to see if this is colliding with the next one. And then again, that's we will have a little bit more checks on the last step that we find the collision in. But then ooh, this is more complicated than I really imagined. Yeah, it's the collision. I mean, I was checking how does Godot do, like there are some game engines like Godot or some other libraries. How do they do collision-based collision for um, in their system? I would like to know maybe if there is an easy way to handle this thing. So let's try to keep this simple for now, I guess. It's not going to be the most efficient way to do it. I guess there's probably a much better algorithm out there that does this. But I can try to just do it step by step and go further with the same tiling system that I have. And then I will require to have 3 steps, probably like the 2R minus 1, and then the 5 pixel thing, 5 or 4, and then the last one is just the 1 pixel thing to get the exact location, and then of collision, and then stop right there. And then we will have an exact location of the player to standing, like after the collision. So it would be really easy to see what happens next. Or I can do something more fun. I can add bouncing ability for the player. So for example, it has some kind of a, but no, for bouncing you would have to also reach to the block. Yeah, we would have to do the same thing for bouncing again. I thought that I can just skip doing this. Okay, I have to do it, I guess. Now the question is that, is it not easier just to do with the platform? Like, imagine if I have a platform here. It's based on node to the object, yes. So collision is made on nodes. Yeah, I have worked a little bit with the Godot, but I don't exactly know like what's the underlying algorithm that they are using. Like there is a system there that is way more sophisticated than of what I'm trying to do. It's much more complicated. I mean, complicated in terms of the technique, not the. It's I think the timing is really fast in terms of time, and like the algorithm complication is really small, and it's really efficient. It's really smooth. But what I'm trying to do here is not exactly the best way to do it, I think, because maybe there is a better way. That's what I'm wondering. But I don't want to also go in looking into all the stuff that is being done into Godot. Maybe there is a easier way, but not too far complicated as, and like not as far complicated as what it is done in Godot. That's what I'm trying to think about. Like that's why I'm talking to myself like a little bit. Like I'm trying to imagine things. Like so, for example, if we remove the tile system completely, if we consider only platforms, could we try to make this structure work with the collision system and not use the tiling, because right now I see that so I am using the tiling to check. Okay, so what does tiling do for me here? If I go to this function here, I'm checking the player if the player move is valid. So the good thing about tiling is that if I know the location of the player, I just need to check the tiles around this player, and I will see if there is a collision. It's really easy. I don't have to look through all the platforms that I might have in the game, and it's pretty fast and it's really really good. But this is too simple because when we are having movement and collision in the game, I will read the chat just a little bit later. So let me finish this. So because in the game we will have the movement, we will have to check all the way from the start of the position to the last, like the new place of the player for the next frame. We will have to sweep this area that player goes through and see if there is a collision in the whole area. And this algorithm doesn't do that. What I've done here doesn't do that. The level algorithm depends on shape per type, simple bounds test for a rectangle, distance test for a circle, polygon intersection, SAT style checks for convex polynomial polygons. Found this within docs. Yeah, that's true. I see. Yeah, I know. I've searched through all of that actually, so I know those things a little bit. I mean, I've searched a little bit, and I know some of those things, like what is the SAT algorithm and stuff. Like, I have seen some of those things. I haven't um, made the code for any of them actually, but yeah, maybe I have to do it now. So I guess that's the easiest way to do it. Just try to do it the hard way. Hmm. But then again, SAT algorithm is more for, so for example, oh, okay, what was the SAT algorithm? Let's go check. What was the SAT algorithm? The algorithm. Where is this thing? Oh, okay, I have to check the view for you to see. SAT algorithm for polygon. Yeah, separate axis SAT. No. SAT is an approach to collision detection. Separating axis theorem. Convex. So the shapes that we are going to have are generally going to be convex, I guess. Is a method to determine if two convex shapes are intersecting. A shape is considered convex. Well, the shape is convex if it's like this. If it's like this, it's not convex. It's like, if it goes inside within the area. It should only, if we try a line, if we draw a line through the shape, we only should hit 2 points. If we hit more points, then it's non-convex shape. We can also do the non-convex shape collision based, but we would have to decompose this non-convex shape to multiple convex shapes, and then we can do use the same algorithm, and it's okay. And so what happens is that the next concept that SAT uses is projection. Imagine that you have a light source whose rays are all parallel. If you shine the light on the object, it will create a shadow on the surface. The shadow is a two-dimensional projection of a three-dimensional object. The projection of a two-dimensional object is a one-dimensional shadow. So the algorithm is that let's discuss how SAT determines two shapes are not intersecting. So basically, we try to find a line. If we can't find a line between two shapes that doesn't hit any one of them, intersect any one of them, that means that these two shapes are separated and there is no intersection in between them. If we choose perpendicular line, and then to do that, we would have to so what we used to do, we would choose every segment, and we would try, for example, for one shape, we do it for this shape, for the non-blue shape. I don't know what's the color, what's the name of this color? Is it pink or is it purple? Anyway, so we make a parallel line with this edge here, and then what did we do next? They may have many. Okay. Further intersections. Okay, I don't understand here what's going on. The line is a separating axis, respective colored lines of the projection of the shape. Projection axis. Not intersecting. Figure 6, two separated convex shapes with their respective projection. SAT may test many axes for overlap. However, the first axis where the projection are not overlapping, the algorithm can immediately exit, determining that the shapes are not intersecting. Because of this early exit, SAT is ideal for applications that have many objects but few collisions, game simulation, etc. Okay, how do you find the intersection exactly? Yeah, here you do one parallel to which one is this? Okay, where is A1? Oh, here. Oh, you find the normal to A1. This is the normal to A2, I guess. A3. Okay. For all axes, the shape projection overlap. Then we can conclude that the shapes are intersecting. Illustrates two convex shapes being tested on a number of axes. The projection of the shapes onto those axes all overlap. Therefore, we can conclude that the shapes are intersecting. Shape 1 does project axis. How do you get the axis? Obtaining the separating axis. The first question I had implementing this algorithm, how to do the axis. Okay, this actually turned out to be pretty simple. The normals of the edges can be obtained by flipping the coordinates and negating one. For example, oh yeah, okay. You just do it normal. You just do a normal and you get one axis. You just subtract one from the other one, and you just to do a perpendicular, you exchange them, the coordinates x and y, and multiply one of them to -1. And then you do it for all the edges of your shape. You have another shape there. You do that for that one too. So for example, my layer thing is a capsule. I guess I have to use the rectangle that covers this capsule, the minimum size rectangle that covers this capsule completely. I will have 4 edges, and I will have 4 normals, 4 axes. And for platforms that I have, they are rectangle. I will do the same. Then, what do you do then? Obtain 2 lists of axes to test. Okay, doing this changes the pseudocode from above to this. And then now that we have the axis, we get one of them, we get each one of them, we project shape 1 with this axis over this axis. Okay, basically, yeah, okay, basically, how do we do the projection? We just find the, yeah, projection of a 2D shape over a line. It's not that difficult. And then you will have 2 projections, and then you will check if there's overlap between 2 projections of the 2 shapes that we have. If it is true, then we continue the loop. If we just find one axis that this thing is not true for, then the overlap doesn't happen, and we can say that they are separated. But this is so AST. The only thing that it's the problem with this algorithm is that it's not enough to find the position. So I can see. So this is not my problem. Major problem that I have in writing the algorithm that I have already is that I want to find the exact location of the player colliding. Like, I want to have 1 pixel before the collision so that I can put the player there, like when the collision happens. That's the complication where SAT doesn't really answer. And for us to do this is that, so to use SAT in our project, we just need to do, so let's come here. So for us to do it, we just need to consider that. So let's consider this. Control C, Control V, thank you. Okay, and then we can draw a line from the top point of this thing to the bottom. And then we want to do that again. Okay. And then this is at the time 0, this is at the time 1. So this is the starting position, this is the end position. And then the thing is that our shape is not exactly a polygon, but what it does, it sweeps over an area. I can do again another line, or I can do an arrow. A line is easier, I guess. It sweeps an area. Okay, what's happening? Okay, another one. Okay, it sweeps an area over here, in between. This area is a polygon. So we can use SAT for this area. And the only thing is remaining is this half kind of thing that we have. And this part should be like, we can consider it as a rectangle for now, but then it's not, again, it's not the best thing. That would be two shapes, and then we have to check, do they collide with any tile there? Hi. What is lead code? I do not know what is lead code. It's a platform like Codeforce, very popular. Lead code. No, I do. So what I'm doing, you mean if the code, if you want to check the code, right? So my GitHub page is live, and you can check that. It's in the description. I'm not doing this. So what is this? It's LeetCode is the best platform to help you enhance your skill, expand your knowledge, and prepare for technical interviews. No, I'm not doing this. I mean, I don't think there is shape collisions here. I don't know. Maybe there is. Is there a shape collision that we can just this is more like here you solve questions related to coding. Yeah, I understand, but it's more for, I don't know how to say, it's like more for what type of projects are there, like the exploration, is it like I don't think that the thing that we are doing is like a 2D platformer. It's kind of a game. It's not like I don't know how to say. It's not. We're not trying to learn the language from basics. I mean, binary tree linked lists. These are interesting stuff, but these are not what we are doing. We could use binary trees and stuff. I mean, B trees is used for games for collision detecting sometimes. Not B trees, sorry, quad trees. Yeah. Data structs and algorithm questions. Oh yeah. I mean, these are the fundamental questions that you can do when learning programming. Yeah, but I'm not doing that, honestly. What I'm doing is a little bit. I mean, it uses a lot of stuff that are here. I mean, but I say a lot. It's not. It's not exactly a lot. It's just it uses some of the notions that are there, but in general, that's not what I'm looking for. But thank you for introducing. So let's go back. We have the SAT. There are shapes. We can do collision detection with these shapes, but this is not what we're. I mean, this is not my main question. My main question is now that do I need the tiling system for the whole thing, or can I just skip it? Are you a game dev? I'm not a game dev now. I'm trying to learn it and be it. So, I mean, so what I'm doing here, I have a code that you can see the code here. It's I'm trying to design a 2D platformer game. I don't know if you know that kind of game. Yeah. Hi, One True Blue. Welcome back. So that's an interesting thing to. Okay, so what was the discussion now? I was trying to figure out, yeah, I'm trying to figure out a way to have 2D collision check. And then, yeah, that's it. I'm just trying to have the 2D collision. I don't know this stuff. Okay, you can continue yours. Continue. I hope you do well. Thank you. Yeah, see you around. So what do we do here? Um, if I remove the tile system, then I will not have the same liberty that I had to check each tile around the player. I will have to find another structure to find the closest platforms to the player and just check only those platforms. And to do that, generally people use some structures. I've heard they use quad tree and stuff. but I have absolutely no idea how they are working, how they work. I can still continue this process with considering a vector. So from like for each move, there is the player position and the new position. I can try to consider that vector and then continue it to the just a little bit so that it covers the new position completely. Oh no, it doesn't have to do it. Yeah, I just need to do it from from player position to the new position. I will consider a vector, and then I will have a length. I will try to cut down this length to tile size, and then like it would be like step by step going forward in the direction that I have, and then finally I will get I will do the collision with these big steps, and then when I get any collision in the jumps that I have, I can make that jump smaller into smaller steps. But that's okay. I can try to do that now, and then I will yeah, I will see if there is a more efficient way, easier way, maybe even not using tile system. Maybe using a simpler approach like a quad tree or some other stuff later. So to do that, I will have the previous position. So what I want to do is I will add an e to this function. I will keep the code in this function for now. I may need it for later. Is player move valid. And then there is a new position, which is a vec2i. What I need to return is a nullable vec2i. So it's null if there is no collision, and it could be a vec2i with some indices if there is a collision. So I will put a question mark vec2i. I will return null at the end, but first, so what should happen is that I will calculate the direction. So const direction is equal to new position minus g.player current position. When we calculate direction, we can calculate what's the size, what's the length of this this movement. I would call it distance. Distance would be dir.len. Do we have such thing in Zig for vectors? I don't remember. I will see if there is an error. I will just write it down myself. So now, if there is, if distance is not equal to, if it's equal to 0, I'm just writing like distance is equal to 0. Okay, Now what should it return? It should return the it just returns the new pose. I mean, it's the same position as the collision, so right? I mean, there is no movement basically. The distance is 0, so return. I mean, the collision would be, yeah, it's. Oh, like this, I can just use this to. No, it's okay. I will have to write a function, I guess, here. Get collision. Okay, if it's not, if the distance is not 0, now we have to do, oh no, okay. If the distance is less than or equal to um, how do I know if I, okay, this is a little bit weird. If the distance is 0, I have to do something. If distance is less than game dot tile size, then I should return also get collision new pose, I guess. I mean, I will have to check these things later. Okay, what do we do? Actually, I can comment these 2 lines, maybe. I don't have to write them. I can define step const step. It's a floating point number. It's basically I to f32 distance divided to I to f32 of oh, that's the number of steps. Okay. Bar start g.player.position while okay, while the distance from start to this thing or bucket, this is better, equal to 0, What is it? It's a floating point. Oh, sorry, F32. Okay, finally I'm trying to figure out this thing. Okay. So if bucket, yes, exactly. If bucket is less than or distance, less than or equal to distance, I guess. It's equal to some step, and then distance is I believe it's it's F32. So this is okay. And then I just need to define the step. Const step is equal to I2 F32 of g.player.r times 2 minus 1. Okay. Then what we do is that we now have a position, new position. I can just say const position equal to g.player.position plus f2i32 some direction multiplied by the distance that I have. Okay, I need to normalize the direction, so I need to define dir normalized. Sorry if I'm not using underline. To do that, I have to change the direction from integer vector to floating point vectors to do that. How I used to do it, I don't remember. Yeah, it was I to vec, yes. I will give direction to this, and then distance. Okay. This now makes sense because I'm dividing by distance. This is much easier to remember, D or N. So this is the normalized direction. I multiply this by buckets. Oh, okay, so direction is a vector, bucket is a scalar, so I have to define a vector for this. Or yeah, exactly. Vec2f, exactly. And then I change this thing, which is a vector, to vec2i. And then I sum these two values to each other. We have a new position. And now in this new position, we want to check if there is a collision between any tiles and the player. So we do that by doing get collision position. And then there should be a result for this collision. Collision. If there is if this thing if there is collision, actually I can just break it's just that I need some index for yeah, exactly. And then here I will increase I every time I pass through this thing. Plus equal to 1. Okay, so whenever there is a collision, which means, yeah, that's like true. I will have to change the function names later. But for now, this should work. But this is not enough. I need to do more. Now, this was the first step, where step 1, basically this step is this thing. This value, which is like 19, I guess. Step is equal to 19. Now what I need to do is to have, so I have the index for which I have a collision. Now I need to do similar thing, but the smaller step to get the exact collision position, like exact position before collision happening. I need to do another while here, probably. Okay, while. So here, while. So now we know that whatever the value of bucket is, it will lead to collision. And then what we need is to, this time we would have to increase it until it becomes bucket plus step. And then what are we increasing? We are increasing the bucket with a smaller step. So for example, 4. And then there is a const position equal to exactly the same thing. If get collision, do that. But this time, var j I32 equal to 0. and this is a G. Okay, that's an interesting thing. So first one finds the collision with the step of, for example, 19. The second one finds collision with the step of 4. The last one has to do that with the step of 1. Var k I32 equal to 0, while bucket okay, so the problem is that so bucket is already in collision. When we get here. So there is something that I have to do so that, so for example, if we get a collision, we need the previous thing. So bucket 0 should never return us, but like it's like having assertion here that bucket is never 0. I assume that bucket will never be 0 here. If the bucket is 0, that means that player in its position like because if it is a 0, this will be 0, so the player in its position is doing collision. And right? No. Bucket could be 0. If it's 0, that means that could be 0, but then in a smaller step, I have to continue. Yeah, okay, bucket could be 0, okay. So how do we continue this part though? Because if the collision happens, then the bucket is in a place that there is a collision, and previous one wasn't collision. Then we need to do a smaller step with the bucket. If this one is a collision, this one is going to be a collision too. So this is wrong. We need the previous one. Or here I need to give the bucket plus step for collision checking. Okay, this seems better. Okay. So this one, for bucket equal to 0, we assume there is no collision. Then we do bucket plus step. If there is a collision, then that means that the next bucket is collision. Oh, no, it's okay. If the bucket is 0, I need to add bucket smaller step and check it again. Then we do this with the smaller step. And then here is a step 2. This is step 2. No, this is step 2. Step 2. Step 2. Step 2 equal to, okay. So bucket is a floating point. I have to do this. This is here. When we do that, okay, and then if we find a collision, we come here. Three, which is the last step, equal to 1, while bucket is less than bucket plus step 2. Plus equal to step 3 exactly. Okay, very good. Okay. This should be working, I guess. There is I, J, and K. I can make this function smaller by making all 3 of them into one loop. I need 3 counters. I need 3 additions per bucket. And then like 3 of these things, 3 values here for condition. And I need 3 steps. And all of them are floating points, I believe. Only these ones are integers. So to do that, I will do this one. They are variables, of course. Counters. Yep. Const step 4, and then this 19. What is 19, by the way? Is this value here? Okay.
Yes, and finally, const condition values, or last values is equal to so the first one is distance minus step. And then this step is s and 0. The second one is bucket plus step 1, step 0, so bucket needs to be defined here. Steps 0, bucket plus step 1. Okay. We do a while. Bucket is less than last values. Okay, for step in steps. Oh no, okay. That's like completely different programming language. Here we do this. Here steps and step and some index I. Okay, very good. What we do is okay, const position. Three of them. Oh, okay, we need to do while. And then here we do bucket is less than last values I. This was oops, sorry. Yep. Steps. Oh no, step. Yeah, that's correct. Do this. Okay. Okay, there's this thing only that is bucket less than or equal because we want to reach the position of the new position. Okay, to do that, we can just make this +1, I guess. Should work. Okay, let's see. I'm gonna comment all of this. I'm gonna remove the extra space that I have put here, so it's easier to go through the code. Okay, what do we do here? So, do I have error somewhere? Oh yeah. This function is not needed for now, so I'm going to comment that as well. Okay, the only thing needed is to define get collision. So what do we have? We have some distance, which is the length of this direction between the two positions of the player, the previous one and the position that we get at the end. Then we try to normalize the direction of the player. And then we define 3 counters because we will have 3 iterations of steps to go from the position that the player is, from the position that player is to the position that the player will be in. And then we'll come back. Gonhases. I don't know how to pronounce that, sorry. I hope that I did it right. So we find the direction, normalize, and then we go step by step. First with the bigger steps. The bigger step is this one, which with the values that I have is probably 19. We first find the collision with the bigger step and then make it smaller with 4 and 1. So those are the steps, and the last values are, so for the first one, we want to start from the beginning, and we want to also check the last place that the player can be in. So I have, because I have less than here, I have to consider the equality as well. So I put a +1 here as well. But I'm not sure about this, like, I don't know, it might lead to some weird bugs. I have a bucket plus steps for, so if we find a collision with in some place along the way with the big jumps, we will have some value for this bucket, which is basically how far we have gone with the big jumps until there is a collision. And the collision is in the next bucket plus, bucket plus steps leads to a collision. So that means that we have to go with the smaller step. And we do smaller step 4, for example, now, in the second iteration. Thing is that I don't really know why I'm using these counters. I don't even use them, I guess. Okay, I thought about something, I guess, in the beginning, but now it's not useful anymore, but I'm gonna leave them for now here to maybe I will realize why I put it there. Why is this here even? The counters, I will not need them, no? Because I'm putting the value all the way inside the bucket. I'm just increasing. Bucket is like the distance that I already have gone from the previous position of the player to the new position of the player. So how far of this distance have I gone? This is the bucket. And I am increasing that with the steps. First with the big steps, and then I make the steps smaller. And I have the direction, and this is the like how long should I consider the vector, and then to get the position exactly. This is good. I get the position. I see if there is collision. If there is collision, I do a break. When I do a break, the next one, the next iteration will happen, and I will see the bucket increase. Okay, with the 4 now. With the middle jumps. With the middle jumps, if I find the detection, then I have a break, and then at the last one, I will have a 1 pixel iteration thing, like increase in bucket, which will help me exactly identify where the collision between the player and the thing will happen. Now, how do I see if there is a collision between the player and anything? It's the same function that I had here. And I actually don't need this to be, I just need it to be true or false. I just need it to be true or false. How do you do that? Get collision. I will define a function here. So I believe these are not needed. I'm going to remove all these comments here. Counter is not needed. I'm going to remove the thing here. Now here, I will keep this function. It's return false. If the tile is blocked, return true. But then this is I will need these things later, but maybe not now. I can just delete them now. Okay. So what's the function name? It's get is colliding. Like I mean, is I have is play platform colliding already. Is player colliding. Okay, I have some kind of player for left side. I need g.player.position. Oh no, not position. I am trying with a new position. New pose. This is new pose. Okay, this is new pose 0. New pose 0. Top is new pose 1. Yep. And then okay. I have to pass it G and position. And the function is player colliding. Ooh, that was a lot to do. Probably there is some weird error bug somewhere. I'm not using this function, but I just fix this thing so that I don't have errors. If like this should be capsule cap rec relator. I will you must capsule circles collide with a flat rectangle. Okay, let's see if there is. Oh no, of course there is error because I didn't change how I call it. Yeah, is player move valid. Okay, here I'm gonna give previous position. I don't think I need that. Yeah, it's okay. It's just that it returns me a collision point. Collision 1, this is collision 2. Again, I don't need this. So now that I have these 2 points, okay. So if collision 2 not collision 1, if collision 1, that means that there is no if collision 1, okay, I will do 1 here. Then put the value of collision 1 in call. Now what do we do with this call? This is the collision point. I mean, this is the point before the collision happening. Pre-collision. That's what we expect to get. or to be more easier, pre-call. Now, what do we need here is that if collision 1 is a value, if it's not null, we will take it as pre-call and then do the next check, which is if call 2 is also not null. I will call this pre-call 2. This is 1. Then g.player.velocity should be 0 vector. And g.player.position should be pre-call 2. Else, if this is null, that means that we have horizontal collision and vertical movement is allowed, which means that g.player.velocity 0 is equal to 0. g.player.position sorry, it's not a position, it's pose 0 sorry. How do we fix this thing? Oh, okay, g.player.position is equal to vec2i of new pos 1 sorry. Okay, 1 is equal to new pos 2 1. Okay, so the y can move, but x cannot move. Here we don't have any movement. Here, sorry, it shouldn't be new pose, it should be pre-collision 1. Right? No. Okay, so the pose should be equal to vec 2i. It's not pre-collision here, it is new position 2. So we get the y from new position 2 because there is no collision with the vertical thing, but because there is a collision with the horizontal thing, we have pre-collision 1. And finally here, I mean, I have to have another thing for another option for when there is no collision horizontally, but there is vertically. collision 2. I will call it again recall 2. G.player. So there is no collision in the x and y. Velocity in 1 should be 0. And G.player.position should be the this one here should be, oh no, okay, yeah, exactly. And finally, what is this else? Okay, G.player.position should just get updated to new position 2, because both are vertical and horizontal movements are allowed. I will comment this one, but I will not remove it because I might need them. Is there anything else to be done? I don't think so. Let's try. This is the last try to run because I have to go now. Well, I will just see. Zig, well, let's see if there is an error. Okay, there is some error somewhere. No field or member function len in vector. Okay, so the length I have to do it by hand. Position, oh yeah, okay, here I also missed the position thing again. And then somewhere I used len. What? Len? Oh yeah. Okay. Okay. So it was math.qrt direction. It was this, no? It's just that math is not defined. I have to go here. Const math is equal to std.math. Zig build. Another error. Direction. Oh yeah, okay, of course. Wherever I've written math, it's a vector, so I have to put it exactly like that. Again, there is another error. scalar and vector operands. So yeah, distance. What a y distance is u16. What? Okay, so direction is integer. I see what you, okay. So I have to do F32 of this thing. I to F32. Yeah, exactly. That's my distance. Distance will be in F32, but then vector to F. Oh, okay, here, yeah, distance cannot be like this. I have to define vec to F because vector to scalar stuff is not allowed in Zig. Is not a function. Oh yeah. Again. Exactly. Another error. Bool found this expected type layer colliding. Right. Okay. Here I have to make this bool. But yeah, okay. Finally. Please work. Ooh, there is no collision detection and there is no gravity applied. Okay, that's enough for today. I'm timed out. I will be back tomorrow doing more of this. I will try to find out what's the problem. Probably the logic doesn't make sense in some way or some stuff. Before doing that though, I'm gonna do git add this git commit dash m. What should I write it though? Oh, step system with collision detection. Git push origin main. Okay, you should see the last changes. Thank you for watching. Don't forget to subscribe and like the video. It will help me a lot for supporting. See you again, and hope to see you again. Love you.